Next up is how to solve the trigonometry questions that involve r cos theta plus alpha or r sine theta plus alpha. So what we've got here is we've got to express this. So 2 cos theta minus sine theta. And I'm going to write 1 sine theta. It's really useful to have a number in between or in front of everything. We've got to put in this format here. So what we do is we need to do the expansion of r cos theta plus alpha. So if you write that as r in brackets cos theta plus alpha, then we need to know what the expansion of cos of a plus b is, or theta plus alpha. Now if we have a look at this here in your formula booklet, we've got cos of a plus b, just take the top signs, equals cos a cos b minus sine a sine b. If you have a look in the formula booklet, the top sign relates to the top sign. So cos of a minus b will be cos a cos b plus sine a sine b. But we are after cos of a plus b, or theta plus alpha. That's going to be cos theta cos alpha minus sine theta sine alpha. So if we do that, that's going to be r, try that again, r of cos theta cos alpha minus sine theta sine alpha. Now because we're multiplying the whole thing by r, that means r is going to go in front of the first thing and then the second thing. So we're going to write down r cos theta cos alpha minus r sine theta sine alpha. And then what we do is we write what we're trying to compare it to underneath. So compare that to 2 cos theta minus 1 sine theta. And now what we're going to do is we're going to compare them. So if we cross out the cos theta and cos theta, we can see that 2 goes with r cos alpha. We see that the 1 goes with r sine alpha. You never need to worry about the sign, because the sign should be the same if you've done it correctly. So then what you've got to do to find out what alpha is, you do this one divided by this one. So that's going to be 1 over 2 equals r divided by r goes, and sine alpha divided by cos alpha equals tan alpha. So if we inverse tan it, again, if we have a look here, we can see that our question is in degrees. So making sure that you calculate it in degrees, the inverse tan over half equals 26 point, and we've got to give this to 2 decimal places, so 26.57. And then you've got to figure out what your value of r is. Now your value of r, and it says your exact value of r, so you keep it as a third, and you do Pythagoras with the numbers here. So with the 2 and the 1, you do Pythagoras with that. That's going to be the square root, so r equals the square root of 1 squared plus 2 squared. So r equals the square root of 5. And if you write it out, that gives you root 5 at the top here, root 5 cos of theta plus 26.57. And that gives us the first 3 marks. Now, what we've got to do is solve this thing here. Now, what we should notice, because it says hence, it doesn't say hence or otherwise, it says hence, so we've got to use what we've just done. So notice that we've just found out that 2 cos theta minus sine theta equals this thing here. So what we're going to do is we're going to replace this thing with that there. So we're going to write that as 2 over, instead of this thing I'll put in brackets over here, we're going to replace that with root 5 cos theta plus 26.57. You've got a minus 1 on the end. That equals 15. So what we're going to do is we're going to bring this up. So we've got 2 equals 15 lots of root 5 cos of theta plus 26.57. If we divide through by 15, we've got 2 over 15 So there, got the -1 on the end of that. Oh, almost forgot. So we've got √5 cos theta plus 26.57 -1. So now you're going to get rid of this -1. So you're going to add 1 onto the other side. So 2/15 plus 1 is going to be 17/15 equals √5 cos of theta plus 26.57. And then if you're going to divide through it by √5, you're going to have cos of theta plus 26.57 equals 17/15 divided by √5, which you can just leave as a decimal. This is give your answer to 1 decimal place. So if we do that, 17/15, and then divide that by square root of 5, we get cos of theta plus 26.57 equals 0.5, I'm going to keep this in there, 0.5068, blah, blah, blah. Now, it's easy to make a mistake here because on the bottom it says √5. So does that mean that we can have plus and minus? And the reason, or the answer is no. We can't have plus and minus of that because this square root of 5 here, remember r is our value of r, and r has to be bigger than 0. So therefore, it is just 0.5068. And then you need to solve that. So it goes to be in a C2 question. So we're going to write down that cos of A equals 0.5068, blah, blah, blah. But instead of being between 0 and 360, we're going to add 26.57. It's going to be 26.57 between theta and 386.57. And if you do that, you then sketch out the cos graph. The cos graph has to 360. If we keep going to 450 there, so 180, you got 90, you got 270, you got 360, and we need to be 0.5068. So 0.50 blah blah blah. You got potentially that solution, and that solution. So what we're going to do is we're going to do the inverse cos of the answer. And we get 59.5. So we've got A equaling 59.5, which is this solution. We're going to do this solution here, which is 360 minus that, which is 300 point, oh, to 2 decimal places. That's 59.55. And then we've got 300.45. And then we've got 360 plus our answer, which is 419.55. Now we needed our answers between 26.57 and 386.57, which means this one is out of it. And we've got to put it back in terms of theta. So what we do is we replace the A with theta plus 26.57. So to find out what our values of theta is, we've got to take away 26.57. So 59.55 minus 26.57 leaves us with 32.98. And you've got 300.45 minus 26.57, leaving us with 273.88. And those are your solutions. So use your solution to part A and part B to deduce the smallest positive value of theta for which that equals 15. Give your answer to 1 decimal place. Now, obviously, it looks kind of simple because if it's the smallest positive value, then sure, it's going to be 32.98. However, it's worth 2 marks, so it's very rarely going to be that simple. And then if you have a look at it a little bit closer, what you notice is that the top one here is 2 cos theta minus sine theta, and this one here is 2 cos theta plus sine theta. So therefore, what you're going to need to do is, if you were to do the whole question again, you do this as r cos theta minus alpha. Is going to be r cos theta minus alpha. And if you do that, you should find out that alpha and r are going to be the same thing. So it's going to be root 5 cos of theta minus alpha. That's right, minus 26.57. And so you do the same thing again. But instead of the theta plus 26.57, this bit here is going to be minus. So you're then going to need to add it on. It's going to be 59.55 plus 26.57. 59.55 plus 26.57, which gives us 86.12. Okay, so yes, it's always worth being vigilant because they'll often link something from the first part of the question to the second part of the question. Now let's have a look at the 2015 paper. So this was meant to be the really tricky paper. So we've got this thing here, and it tells you to expand it and put it looking like that there. So in exactly the same way, we're going to do the expansion for this. And once you've done it a couple of times, you can say that that's going to be r cos, and it's going to be cos 2 theta cos alpha plus r sine 2 theta sine alpha. And what you should see is that if you remember, the cos got a minus there, it's going to have a plus in the expansion because there's a plus here. And then if you write the other thing below it, say 4 cos 2 theta plus 2 sine 2 theta. Once you've done that, you compare them. So get rid of the cos 2 theta, and you've got r cos alpha equals 4. Get rid of the sine 2 theta, and you've got r sine alpha equals 2. So in exactly the same way, if we do this one divided by this one, 2 divided by 4, you're going to have a half. So you're going to have tan alpha equals a half, and just like you did last time, the inverse tan of 0.5 gives us 25.57. And again, this one is in degrees. Just be careful that it's in degrees. And then we've got to figure out what r is, except this time r is going to be Pythagoras using 4 and 2. So r equals the square root of 4 squared plus 2 squared, which equals the square root of 20, which you might want to write down as 2 root 5. And that's it. You're not asked to put it in that form. You're just asked to find out what r and alpha are. So we've got 26.57 and 2 root 5. Hence, we've got to solve this. So that's this thing here. So hence means that we've got to use part A. So we've got this thing here, which is what we've just done the expansion for, equals 1. So we're going to write that 2 root 5 cos of 2 theta minus 26.57 equals 1. All we're doing is we're taking this and replacing it with this thing here, where r is 2 root 5 and alpha is that 26.57. And we're setting that equal to 1. And then we do exactly the same as we just did a second ago. So we've got to get it so it's cos something equals. So we divide through by 2 root 5. So we've got cos of 2 theta minus 26.57 equals 1 over 2 root 5. And just like before, we can't do anything now. It's got to be cos of something. So it's going to be cos of A equaling 1 over 2 root 5. But now what we do is we've got to change the bracket. Sorry, we've got to change the limits. So because inside the brackets we've got this thing here, 2 lots of theta minus 26.57. We're going to do 2 lots of 90, take away 26.57, and 2 lots of minus 90, take away 26.57. So we're going to say that A is between, we do 2 lots of 90, and then take away your value of x, you get 153.43. If we do 2 lots of minus 90, take away 26.57, you get minus 206.57. So once you've done that, you're then going to draw the cos graph out. So the cos graph between minus 206.57 and 153.43. So there you go, that's 90 and then 180. That's minus 90 and then minus 180. And then because it goes past that, you might want to go up to that there, which is minus 270. Now what we've got to do is we've got to solve 1 over 2 root 5. So 1 divided by 2 root 5 gives us 0.22. So therefore we're going to have two solutions. We're going to have this one here, and we're going to have this one here. So therefore if we do the inverse cos, find out the first solution, that's 77.08. And also this one over here is going to be the minus version of that, so minus 77.08. That's what A is, but remember that A is going to be two lots of theta, and then minus 26.57. So in order to get what theta is, we need to do the opposite of that. So if 2 lots of theta minus 26.57 equals minus 77.08 and 77.08, what we're going to do is we're going to add 26.57 and then divide by 2. So we've got times by 2, and then take away 26.57, and we get 127.59. 127.59. Then if we do the other version, again, if you go back, they don't make any rounding errors. So we're going to add 26.57 divided by 2. We get, in fact, I think I may have made a mistake there, so minus 25.25. Yeah, so my other one was a mistake, that wasn't 127.59 at all. You had to add 26.57 divided by 2, and that should have given us 51.82. I'll blame the heat. So, to one decimal place, so therefore round that to 51.8 and minus 25.3. It says that given that k is a constant, that the equation g of something has, or g of this, has no solutions, state the range of possible values of k. So let's see where we can, let's see what the answer to this is. So given that k is a constant, and we're saying that g, remember we can write g of theta as this thing here, which I've left. And we're going to set that equal to k, and that is not going to have any solutions. So the first thing you do here is you do cos of 2 theta minus 26.57 equals k divided by 2 root 5. Now if it's got no solutions, what that means is that we can't do the next step, we can't do the inverse cos of it. And the only thing we can't do the inverse cos of is if it's bigger than 1 or less than minus 1. So what we've got to say is k over 2 root 5 is going to be greater than 1. And then that k over 2 root 5 is going to be less than minus 1. because then we can't do the inverse cos of it. We can't do the inverse cos of 1 or minus 1 because that's what the cos graph goes up and down to. So then if we rearrange that, we've got to say that k is greater than 2 root 5 and k is less than minus 2 root 5. And those are the range of possible values of k, which means that we can't get any solutions. So that was a 2015 paper, the trickier one. And then again, question 9 on 2014. So it's going to be one of the later questions, so it's going to be quite a hard one. But again, don't beat yourself up too much if you can't get the last bits. It's this first bit that we've really got to look at. So this one here, r sine of theta minus alpha. So if we have a look at the formula booklet, if we're doing sine of theta minus alpha, then we've got minus, which is the one on the bottom here. So sine of a minus b, and that's going to be sine a cos b minus cos a sine b. So if we apply that to r's, where are we? Here we go. Then we've got r sine theta cos alpha minus r cos theta sine of alpha, and that's the expansion of this thing here. Again, make sure you know how to do these expansions, because as soon as you've done that and then you put the other one next to it, so the thing that we're comparing, 2 sine theta minus 4 cos theta, we then knock out the sine theta, so we say that 2, which we're left with, is equal to r cos alpha. We say that 4 equals r, we knock out the causes, sine alpha. So in the exact same way we do the sine divided by the cos, that leaves us with 4 divided by 2, which is 2. R divided by r disappears. Sine alpha over cos alpha equals tan alpha. And then here we've got to make sure our calculator is in radians, so switch your calculator to radians. And we do the inverse tan of 2, and we get alpha equals 1.107. And then we want to find out, oh, that was just the value of alpha. So that's it, that's just the value of alpha. What I'd always do though is work out what the value of r is as well. Oh no, so we've actually got to express it in this format, so we do have to find out r. So r is going to be the Pythagoras, so r equals the square root of 2 squared plus 4 squared. So r equals the square root of 20. So r equals root 4 root 5. So r equals 2 root 5. We've got to express it in this format. We can finally say that 2 sine theta minus 4 cos theta equals 2 root 5, which is r sine theta minus 1.107. And that's part A done. So that's part A. Part B, give the value of, oh no, sorry. We've got h, which is this. Find the maximum value of h. Now usually the maximum is just this value of r here, and the minimum is the negative version. However, it is a little bit different this time, because we're not looking at just this thing here, or just this thing here. We're looking at that within a function. So we've got h of theta equals 4 plus 5 lots of 2 sine 3 theta minus 4 cos 3 theta squared. So let's rearrange that to what we know. So there's 4, there's nothing much we can do with. The thing that we know is about 2 sine theta minus 4 cos theta. So we know that's going to be 2 root 5 sine, but this time it's not theta, it's 3 theta. So it's going to be 3 theta minus 1.107 squared. And we've got to work out what the maximum this could ever be. Now, we know that the maximum value of r, the maximum value that this thing inside the brackets could ever be, is our value of r. Because remember, r is usually the maximum or the minimum, or the negative thing is going to be the minimum. So the maximum inside this brackets here could ever be is going to be 2 root 5 or root 20. And then what we're going to do, or what they're going to do, is they're going to square it. They're then going to times it by 5, then add 4. So root 20 squared is going to be 20. Times it by 5 is going to be 100. Add 4. So the maximum value is going to be 104. So we've got to work out the smallest value of theta at which this maximum value occurs. So if we think, and this is a sin graph that we're looking at here. So the sin graph looks like this. So the maximum the sin graph is at this point here. And that's when it's 90 degrees or pi over 2. So it means that because we're dealing in radians here, to make this the maximum, this bit here has got to be the maximum. So this bit here has got to be pi over 2. So we're going to set 3 theta minus 1.107 equal to pi over 2. So then we're going to add 1.107, divide through by 3. So if we do that, we should get 0.893. And that's part B done. So that's 3 marks there. Next, we've got to find the minimum value. Now, usually the minimum value is just the negative version of that, but it's not going to be minus 104. Again, we're going to use a similar thing to work it out. But we've got to use our brains on this a little bit more. So if we have a look at this here, we're going to, whatever's inside this thing here, we're going to square it. So we can't have that as something negative, because if we square it, it's going to be positive. So if we're going to take something here, which I've put in the curly brackets, and we're going to square it, the smallest we can ever make that is if it's going to be 0. So 0 squared is going to be 0, times by 5 is 0, then we're going to add 4. So the minimum value is going to be 4. And the largest value at which this minimum value occurs, so, oh, that's the largest value. So what we've got to do is we've got to find the value of theta. So we're going to do 3 lots of theta, take away 1.107, and that's going to equal 0. So what we're going to do, in fact, because we've got this 3 here, we're going to draw 3 times the sine graph and then take a 1.107. So that's 1, 2, 3, and then a little bit more. So that's going to be pi over 2. That's going to be pi. 3 pi over 2. 2 pi. 5 pi over 2. 3 pi. 7 pi over 2. So I want to know whether or not we can make this 0. So 3 lots of theta minus 1.107. Can we make that equal 7 pi over 2? And that way, would that leave us a number between 0 and pi over 2? So if we do that, 7 pi over 2 plus 1.107 divided by 3 is 4. So that means theta equals 4.034. So that's not going to work. Let's try it with 3 pi and see if that gives us an answer in between 0 and pi over 2. And you can keep on trying it, but then if you come across 2 pi here, and we set 3 theta minus 1.107 equal to 2 pi. If we then add 1.107 and divide by 3, we should get theta equaling 2.463. And that will give you the answer. So well done if you managed to do all those.